Hello physics students. In this video I'm just going to introduce the concept of momentum conservation for an isolated system. In the next video we're going to talk about what an isolated system is. In the last video we learned a little bit about Newton's third law and just kind of went into that a little bit. I'm just going to read a description of momentum conservation principle, and it says, for a collision occurring between one object 1 and object 2 in an isolated system, and I'll talk about that in the next video, but essentially an isolated system is one in which there are no outside forces interacting with those two objects. The total momentum of the two objects before the collision is equal to the total momentum of the two objects after the collision. That is, the momentum lost by object 1 is equal to the momentum gained by object 2. All right. Now I have just some illustrations, and we're going to talk about why that is the case in just a minute here. So the logic, the reasoning behind this is for two objects colliding, right? If I have my handy demonstration, Physics Pony, and, Physics Pony is going to collide with this truck here. This is now a truck. Physics Pony and the truck collide, and then they kind of roll together because Physics Pony is really strong. They move this way afterwards. During the collision, wham! When they collide, the forces are equal and opposite, and we learned that during our lesson on Newton's third law. The time of the collision, right? As soon as they collide and then are apart from each other, the forces no longer exist. Remember, forces are only occurring when two objects are touching or interacting with each other at a distance. And these two objects, once they stop touching, there's no more force on them, at least from each other, right? So force 1 equals negative force 2, and time 1 equals time 2. And so, just putting it into an equation, force 1 multiplied by time 1, that's impulse, right? Force multiplied by time, equals negative force 2 multiplied by time 2. So, and remember, our impulse equals an object's change in momentum, right? And so we're going to substitute our change in momentum for each of these impulses. So, mass 1 multiplied by our change in velocity of object 1 equals the opposite change in velocity of object 2 multiplied by object 2's mass. Meaning, the change in momentum of this object equals the negative change in momentum of that object. And we're going to delve into this with a little bit of example that I think you all will be able to easily follow. We're going to talk about money. We're going to talk about two people, Jack and Jill, and they each have $100. And so the two of them combined have a total of $200, right? 100 plus 100 is 200. All right. So Jack and Jill each have $100. Jill approaches Jack, who is the owner of not Physics Pony, but someone like Physics Pony, and Jack is like, oh my gosh, I really, really, really want your Physics Pony doll. Can I buy Physics Pony from you? Please, 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 Jack. Please, Jill, can I think Jack was buying from Jill. Anyway, Jack, really, really wants Physics Pony from Jill. So, Jill says, yeah, it's a really, really special to me, but I'd sell you Physics Pony for $50. Jack's like, done. I'll do it. I just want Physics Pony. So Jack loses $50, so he now only has $50, but plus Physics Pony. And Jill now has $150. The total they have, oh, and Jill has Physics Pony here. All right. So Jack gets Physics Pony. Jill gets an additional $50, and total, the money between the two of them still equals $200, right? So the total money before equals the total money after. This is conservation of money, right? It's an exchange of goods and services, but very, very similar to what we're going to be doing with momentum conservation. And so our change here, Jack has lost minus $50. He did gain a very valuable asset, Physics Pony, but we're just going to be talking about the money side of things. And Jill gets a positive $50. And this is what I was talking about over here with momentum, that the negative change for Jack is equal to the positive change that Jill experiences, right? And so the total amount of momentum in a system is going to stay the same, the total before, the total after. However, our change for each object is going to be equal and opposite. In the next video, we're going to delve into just a little bit more on what an isolated system means, as just a conceptual understanding for a system of objects and what that is. And then in the following video after that, we're going to go into just a couple of example problems of momentum conservation, just to help you understand. I know that hopefully this provided some context for what I was talking about. But in the next couple of videos, we'll go into the actual momentum problems, how to set them up and solve them. Thanks for watching, and we'll see you in the next video.